Now this is the given problem, and in this particular problem we are interested in the calculation of current in 20 ohm resistance for the network shown below using Thevenin's theorem. So we want to use the Thevenin's theorem here for the calculation of the current in 20 ohm resistance. Means what is the load? This is A point and this is B point, and this is our load resistance. First step is remove the load resistance and redraw the same circuit. Redraw the same circuit. I will use the same procedure here. I will write here. Removing load resistance and redrawing the same circuit. Is it right? If I am removing the load resistance and if we are redrawing the same circuit will be something like this. There is the load resistance which we are removing. This is load resistance, and we are redrawing the same circuit. It will be something like this. Yes. This is A point, this is B point. Sorry, I forgot this value. It will be the 2 ohm. This is 2 ohm. This is 2 ohm. It is 2 volt. This is minus. This is plus. It is 5 ohm. This current is the 2 amperes. This is 5 ohm. This is 3 ohm. And it will be the 100 volt. This is plus and this is minus. Is it right? Now here, in this case, I want some answers from your side. I want some answers from your side. इस फिगर को इस तरह से भी दिखाया जा सकता था. इस फिगर को, this figure can be shown something like this. ये जो इस तरह दिखाया है, it can be shown in the different ways. It may be something like this. ये कुछ इस तरह से भी हो सकता था. How it is? Yes, also. There are a number of ways to represent the same figure. इस तरह से भी दिखाया जा सकता है. This will be the 20. Is it right? And this is 2 ampere, and this current is the 2 ampere, and this will be the 5 ohm resistance. Is it right? This combination can be shown something like this. That may be the case. Now here I will come back to you, and we will discuss few things, and then we will try to solve this problem. Yes, I'm coming back to you. Now here I will expecting the answers from your side. Which method we will use, because here we are interested in the VTH. Is it right? Means potential between this B and A and B points. Means we will travel from the B towards A. Means we are interested in the calculation of current in 5 ohm. Which method we will use that will make the calculation simple? I want the answers from your side. Which method will be simple for the calculation of current in 5 ohm resistance? You can use any method. Yes. Someone.
Sir, super mesh.
Super mesh. Right. Super mesh will be the one of the options. Here we can apply the KVL to this loop. That is one equation, and another equation we can find it. बिल्कुल सही. But that is not the only one way. You can use the nodal analysis also. लेकिन वही मेथड यूज करना है जिसको आपको कंफर्ट लगता है. Is it right? But if we are practicing on one of the method, then that method will be more simple. Is it right? मुझे पता है आपको तो mesh analysis will be the simple one, but again here in this case, I will discuss the multiple methods and then I will discuss the solution in this case. Now look at carefully. We can use the nodal analysis also, because this point we can shift here. This point we can shift here. It's one branch, second branch, third branch. इस branch में current नहीं जाएगा, इस branch में current नहीं जाएगा. That's why no need to think about those branches in case of the nodal analysis method. Is it right? Otherwise, what is the second option? This is current We can convert this current source into the voltage source. अगर इसी current source को हम voltage source में convert करेंगे तो circuit कैसे होगा? Look at carefully. It will be something like this. This will be the battery, and it will be something like this. We are shifting this and converting this current source into the voltage source. Upward direction है तो positive ऊपर रहेगा. This two branches will be replaced by something like this. This will be the 5, and how much is the voltage? 5 to the 10 volt. And here it will be the 2 ohm. This will be the battery. This is A terminal, and this will be the B terminal. This is another option. In that case, this is the simple loop. Apply the KVL to this loop and find out its equation, which is the current I. Then travel from the B towards A. That will give the same value. Is it right? This is the second way. First, जो अभी discuss किया, that is the super mesh from your side. This will be the second way. And third approach is nothing but use the nodal analysis method. उस समय ये assume करना है कि ये जो open वाले branches है, whatever these branches are there, these open branches are not existing in the circuit. ये मान लेना कि branches सही नहीं. Is it right? Now we have the simple figure. How is the figure? This is one branch, second branch, and third branch. How many nodes we have? We have the 2 nodes. Now here in this case, this will be the simple approach you can use, or you can use the super mesh. But here I will use the nodal analysis. Is it right? This is nodal analysis. This is node A having its potential VA, and this will be the ground node. Is it right? Assume the separate currents here. Assume the separate currents here, and in this case, this is the current I1. This is the current I2. I'm assuming the same direction, and this current is the I3. Is it right? This current is the I3. Use any method. Many times I used to prefer the nodal analysis क्योंकि majority students nodal analysis में comfort नहीं होते हैं. That's why to have a practice, majority times I'm using this nodal analysis method. But simple is the mesh analysis if you are comfortable, or maybe any other method in which you are comfortable. Is it right? Now I will complete this. So here applying KCL at node A. If we are applying the KCL, that is Kirchhoff's current law, at the node A, we will prepare its equation. How will be the equation? This is incoming, this is incoming, this is outgoing. This equation will be I1 plus I2 is equal to I3. Is it right? I1 plus I2 is equal to I3. How much is the value of I1? 0 plus 100 minus VA. We said it is 100 minus VA divided by the resistance of this branch. 5 plus 3. 8. This is right. This is 8 plus. I2 is the current in this branch. How much is the value? 2 amperes, which is equal to. Current in this branch is the I3. How is the equation? VA minus 0 divided by its resistance. This VA divided by 5. This is the equation for I3. If we know this equation, then we can find out the potential VA. If I am simplifying this equation, it is 100 divided by 8 minus it is VA divided by 8 plus 2, which is equal to it is VA divided by 5 is the value. Is it right? Now if we are shifting this VA to the next side, how will be the equation? This VA, I will take it as common. It is 1 by 8 plus it is 1 by 5, which is equal to. It is 100 divided by 8 plus 2 is the equation. Find out the both values. lecture. So here in this case, this is the equation. How much is the value on the left hand side? Yes. Yes, Saurabh, unmute yourself.
0.32 VA.
Sorry?
0.32.
0.32 VA is equal
to 14.5.
14.5 is this equation. Means if we are finding the VA, which is 14.5 divided by 0.32, how much is the value? Yes.
40.31.
Sorry?
45.31.
45.31 volt. Is it right? If we know the voltage, then we can find out its current I3. This I3 is equal to, what is the equation? VA divided by 5. It is VA divided by 5, which is equal to 45.31 divided by 5. How much is the answer? I3. Anyone? You can unmute yourself. Rishikesh, Ruchira, Madhuri, Saurabh, Shailesh, Naushad.
9.06.
9.06 amperes is the I4. I will check with someone. Yes, anyone has answer?
Sir, correct.
Correct. Okay, fine. If we know the value of I3, then we will find out the value of VTH, which is equal. It is modulus value. We are traveling from the B towards A. ये direction नीचे है, means this is plus and this is minus. If we are traveling in this direction, how much is the voltage across this? 0. Because current in this branch is 0 because it is open circuit. There is no path for the current. Then if we are traveling upward, negative to positive, that is a plus. Its resistance is a 5 and its current is I3, which is 9.06. Then we are traveling back. How much is the voltage across this resistance? Which is 0. Because current in this branch is 0. Means it is plus 0. Then negative to positive, which is a plus, its voltage is a 2. And that's it about the calculation of VTH. How much is the value?
47.3.
47.3 volt is the value of VTH. If we know the value of VTH, the next step is the calculation of RTH. I will write the same. For calculation of RTH, load resistance is removed and all sources are replaced by respective internal resistances. Is it right? Now we will remove all the sources by the respective internal resistances. This is the voltage source. Its internal resistance is 0. This is current source. Its internal resistance is infinite. This is voltage source. Its internal resistance is 0. This figure will be something like this. There is one resistance. This is another resistance. This is right. This is the third resistance, which is here. And this is the next. And this is the A point and this is the B point. Is it right? There is another resistance. Its value is a 5. This value is the 2. This value is the 2. This is 5. And this is again 3 ohm. Its resistance is the 3 ohm. Is it right? So here in this case, we will use the series and parallel combination. We will use the series and parallel combination and we will try to find out its value. Now look at carefully here. If we are looking at the series and parallel combination, how will be the first combination? In this case, these two branches are in parallel. I will draw that figure somewhere here. These two branches are series replaced by one resistance. It will be something like this. This is the second. This will be the third, and it will be the fourth. This is A. This is B. It is 2 ohm. This is 2 ohm, and this is the 5 ohm. And these two branches are in series. 5 plus 3, 8. This is 8 ohm. Now next, these two branches are in parallel combination. This is next figure will be something like this. Here is the point A, this is the point B. It is the 2 ohm, this is the 2 ohm. And how much is the parallel combination of these two? Anyone?
Three point zero seven.
3.07 ohm. If we know this value, I will come back to you. If we know this value 3.07, then RTH is equal to, this RTH is equal to, how much is the value? This is series combination of all. 2 plus 2, 4 plus 3, 7. Is it right? That is 7.07 ohm is the value of RTH. Now, if we know the value of VTH and RTH, then complicated network will be replaced by the simple network, which is nothing but the Thevenin equivalent network, and we are in a position to find out its value. Is it right? Now here, I will write the same. If we know VTH and RTH, then complicated network is replaced by Thevenin's equivalent network. Thevenin's equivalent network. How will be the Thevenin's equivalent network? This is the Thevenin's equivalent network. There is A point, this is B point. RTH 7.07 ohm. How much is the VTH which we have calculated this value? If we have calculated this VTH which is 47.3, is it right? This value is 47.3 volt is the VTH. How much is the load resistance? This is 20 ohm. Means load resistance is the 20 ohm. I will reconnect the load which is of the 20 ohm and calculate current in this branch which is I or IL. Now this IL is equal to total voltage which is 47.3 divided by total resistance 7.07 plus 20, find out its load current.
$1.74 ampere.
Sorry?
1.74 ampere.
1.74 ampere is the value of IL. I will check with someone again. Yes. Anyone has the answer? Yes, Theorem.
Correct, sir.
Correct. So here in this case, we have calculated this load current which is the IL. This is the calculation of the current using this method which is the Thevenin's theorem.